Hello, and welcome to Chemistry Talk with Hunter. I'm Hunter, and today we'll be discussing electron configuration and mainly writing the electron configuration of elements. I just wanted to give a brief overview of how I'm going to do it and how most instructors teach you how to write electron configuration. Is the periodic table is already arranged in increasing electron affinity and increasing electron subshells. What I mean by that is there are a couple types of subshells. There's an S subshell, a P subshell, a D subshell, and an F subshell. The S subshell can hold 2 electrons, the P subshell can hold 6, and the D subshell can hold 10. So it increases from S to P to D to P. It just keeps going, increasing, as you can see. So to give you an example, if we wanted to write the electron configuration of boron, we would start at hydrogen at 1s1, go to helium. Now we're filled the 1s2, our 1s subshell is filled, so because it can only hold 2 electrons, so we're at 1s2. Then we're at lithium, and we're going to be 2s2 because we're going past beryllium, so our 2s subshell will be filled. And now we're at 2p. Now the 2p can hold 6, but we're only going to have 1 because boron's the first one. So it's 1s2, 2s2, 2p1. And that is the configuration of boron. So if you're not comfortable with the electron configuration table yet, maybe you should do a little bit more studying and perhaps see another video on my channel where we discuss atomic theory, electron configuration laws, and how the table is arranged before watching the rest of this video, as I won't be referencing this table at all. So let's get started. And by the way, memorizing the electron configuration table and writing it out on your own periodic table is not challenging. It just requires a little bit of memorization and practice. So take your time when you're given a test and you're given a periodic table blank. Make sure you write it correctly, or if you don't need to write it, make sure you're doing it correctly so you don't lose points. So let's get started. Our first example is sodium, and sodium has an elemental symbol of Na. Now, all of these start off the same, what we just did. We start off at 1s2, then we go to 2s2. Now we're at 2p6. We're going to fill up the whole p subshell because we're going past neon. And then we arrive at sodium, which is 3s. Now, like I said, the s subshell can hold 2 electrons, but guess what? We're only going to need 1. Because sodium is the first element in the 3s subshell. So the full electron configuration for sodium is 1s2, 2s2, 2p6, and 3s1. Now we're going to do bromine, which is our next example. Now bromine's further down, so that means we're going to have a lot more configuration to do, which is fun. We'll start off the same as sodium, 1s2, and that's a little sloppy. 1s2, 2s2, 2p6, 3s2 now, because we're filling up that whole subshell. Now we're at 3p6. Now we're at 4s2. We're at calcium, but now it gets interesting, because we're going into the D block. Now you might think that the next one would be 4d, but it's not. It skips a number, just part of the law. So it's 3d10. We're filling up that whole subshell. And now we're at 4p. Now bromine is the 5th one in, so we're at 4p5. So our bromine's electron configuration is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, and 4p5. So it looks really confusing if you don't know how to do it, but it's not that bad. Okay. Next, I'm going to put that here. Next, we're going, the directions say to write the noble gas electron configuration. And our first one is tellurium. Tellurium. Wow, that's a hard one to pronounce. So, tellurium has the elemental symbol of Te. Its atomic number is 52. That just helps us find it. Now, when you're doing the noble gas configuration, you want to look up and to the right of the element because you're looking for the nearest noble gas, and in this case, that happens to be krypton. Now, to make the noble gas configuration, all we're doing is writing the electron configuration for tellurium or any element after the noble gas. So we start off after the nearest noble gas, which means you're always going to be starting in the S subshell, whether that's 5s, 4s, 1s, doesn't matter. But in this case, we're going to be starting off at the 5s subshell. Now we're going to fill it up. We're at strontium now. We're going to fill up our 5s subshell. Then we're going to the 4D column. So we're going to fill up 4D10, the row. Then we reach our 5P row. But tellurium is the fourth one in. So it's just 5P4. So notice it's just the electron configuration after krypton for tellurium. It's not the whole thing. It's just after the noble gas. So how we write this is we put our noble gas in brackets, and then we write the electron configuration after. So this just makes it easier for ones that are really far down, and it's also good to for tests if you're given the noble gas configuration in order to identify what element it represents. So this is the noble gas configuration for tellurium. Next, we're asked to do it for radium. Now, radium's atomic number is 88, so we're all the way down. And our nearest noble gas is radon. Both are, so don't get confused, radon. So, in order to write the noble gas configuration for radium, we're going to go to the next S subshell, which is 7. And look, radium's the second one in, so it's 7s2. Not too bad. Rn goes in the brackets, and it's 7s2. Let me rewrite that down here. Rn, radon, goes in the brackets, our nearest noble gas. 7s2 goes there, and that is the noble gas configuration for radium. Now, there's one more type of question you could get with these, and that's just simply giving you the full electron configuration, not the abbreviated one, and asking you to find the element it represents. So there's a couple ways to do this. You can write along with the configuration and just follow along in your periodic table, or you can look at the last subshell filled. So in this case, the last subshell filled is 5s1. So that means that we definitely didn't fill our 5s subshell. We're the first one in. And since it's the S, we're going to be on the left-hand side. So I'm just going to count down 5. 1, 2, 3, 4, 5. And look at that. I found our winner, rubidium. So this configuration represents rubidium. And once again, I can tell that by either writing the full electron configuration, following along, and then reaching it, or looking at the last subshell filled and finding it on your periodic table. And in this case, it's 5s1, so I found our culprit, and that's rubidium. I hope this helps with your writing of electron configuration. Like I said, a future video is to come on atomic theory and configuration laws. If you have any special requests for videos for me to do, please leave it in the comments, or if you have any questions about electron configuration, feel free to ask as well.